Hello students, this is the third part of important topic functions. Yeah, in part 1 and 2 I explained about the definition of function. Okay, how to find domain range of some simple functions. So, and vertical line testing. So, today I am going to explain some problems based on our previous concepts, students. Yeah, this is subject to problem set 1. Some problems are given. Which of the following correspondings can be called functions? Some correspondences are given, some relations are given. We want to check those relations are used, functional relations or not. I will explain one by one, students. For example, first one is given as rule. Rule is given as f of x equal to x cube, sorry, f of x equal x cube. Yeah. Domain of the relation, I am saying relation because I don't know that is function or not. Domain of the relation is given as minus 1 comma 0 comma 1. Okay, codomain of the relation is given as 0 comma 1 comma 2 comma 3. Now using Venn diagram I will explain. This is set A, this is set B, having minus 1, 0, 1, 0, 1, 2, 3. Okay. So if you take x is taken as minus 1, yeah, minus 1 cube, that is called minus 1. So actually minus 1 not there in codomain, means there is no image for minus 1. If there is no image for minus 1, automatically the relation doesn't gives a functional relation. All the elements of first set should be used up, no? If taken x is minus 1, so what I will get by y equal to minus 1, but minus 1 not there in codomain. That's why directly I can say that it is not a functional relation. So I will write if x equal to minus 1, then y is equal to f of x, that is y equal to f of minus 1, that is equal to minus 1 or cube root of or minus 1 cube I can say. So y equal to minus 1, but minus 1 doesn't belongs to B. So f is not function. F is not function means f is not functional relation. So what I can say, this is not a functional relation. Next students, next one, f of x is given as plus or minus root x, either plus root x or minus root x, both should take. So first of all I want to find what is the image of 0. F of 0 equal plus or minus root 0, that is equal plus or minus 0, 0 only, no plus or minus, no. F of 1 equal to plus or minus root 1, that is actually root 1 means 1 only, na? Root 4 means 2, don't say that a plus or minus, that is wrong. Root 4 means 2 only, 2, but here plus or minus given, that's why I can say minus 1 comma plus 1. In general, students, root 4 means 2 only, not plus or minus 2, should take care. F of 4 I want, plus or minus root over 4, that is plus or minus 2. Okay, now I want pair. Yeah, this is A, say this is B, this is F, here 0, 1, 4 given, actually here minus 2, minus 1, 0, 1, 2. According to the rule, 0 should paired with 0. 1 paired with minus 1 as well as plus 1. What happened? 2 used up 2 times. That's why with the definition of function, it is not a functional relation. Similar 4 also paired with minus 2 and as well as 2. F is not a function. What the reason means? The elements of A are used more than once. Or you can say that f of 1 is minus 2, f of 1 also 2. Sorry, f of 1 is minus 1, f of 1 also minus 1. That is the reason. That's why given function is not a functional relation. Okay, just a relation, another one. Yes, students, third one, not third one, C. F of x equal root x. Yeah, f of 0 I want, that is root 0, 0. F of 1 I want, root 1, that is 1. F of 4 I want, root 4, that is 2. Student, this is A, this is B. A having 0, 1, 4. Actually B having minus 2, minus 1, 0, 1, 2. According to this rule, 0 paired with 0. 1 is paired with 1. 4 is paired with 2. Okay, functional relation only, no? All the elements of A are used up only once. With the definition, f is a function from A to B. F is a function from A to B. Okay. Yeah. Next one, students, D. F of x is given as minus root over x. F of 0 I want, f of 0 equal minus root over 0, 0 1. F of 1 I want, minus root over 1, that is equal minus 1. F of 4 I want, minus root over 4, that is equal minus 2. Just filling A, B, 0, 1, 4, minus 2, minus 1, okay, 0, 1, 2. Because rule 0 should pair with 0, 1 paired with minus 1, 4 paired with minus 2. So all the elements of first set are used up only once, therefore f is a function from A to B. F is a function from A to B. Okay students, this is the answer for the first problem. So finally what happened, is not a function, functional relation, is not a functional relation. Yeah, this is the functional relation, this is the functional relation. Okay. Now our next problem, interesting problem, second problem. Let g of x be a function, clearly given g of x be a function defined on minus 1 to 1. Minus 1 to 1. Defined on minus 1 to 1, this is the domain of the function, so that should take care. If the area of the equivalent triangle with two of its vertices are 0, 0 and x, g of x is root 3 by 4 square units, then the function g of x may be, we want to find g of x function. Students, interesting problem. Listen students. First of all, equilateral triangle is given, say ABC. Two vertices are given, this is 0, 0 and this is given as x, g of x. Let side of the function, side of the equal triangle is small a. All are equal to a only, no? I will write side of triangle. Triangle means equal triangle. Equal to A. That equal to BC equal to AC equal to AB. Because it is equilateral, no? A equal to, yeah, BC length I want one, BC length, BC. X minus 0 whole square. Everyone knows how to find distance between 2 points on the coordinate plane. X2 minus x1 whole square plus y2 minus y whole square root over. So I can say g of x minus 0 whole square. This is side nana. A equal to root over x square plus g of x whole square. This is the side. Now I want to find area of equal triangle. Area of triangle ABC equal to, actual what is the formula? Root 3 by 4 into side square. Any equal triangle, if side is given as A, then its area is root 3 by 4 into A square. According to the problem, this is given as root 3 by 4. Root 3 by 4 equal to root 3 by 4 into side square means A square I can say. Root 3 by get cancel. A square equal to 1. Okay. So I will write next page nana. So that is A square equal to 1. A square means what? X square plus g of x whole square equal to 1. Observe here. Just now I proved, no? A is that. So you want g of x whole square. G of x whole square equal to 1 minus x square, but I want g of x, nana. Applying square root on the other side, this is involving variable, here also involving variable, actually we need to use modulus. Mod g of x equal root over 1 minus x square. Therefore, g of x is equal to plus or minus root over 1 minus x square. But already in previous example I explained, no, f of x is taken as plus or minus root x. It is not giving functional relation. If you take f of x equal root x, giving functional relation, f of x taken as plus root x also giving functional relation. If you take here plus or minus, it won't give functional relation. That's why I can't say that g of x is plus or minus root over 1 minus x, but I can separately I can say that therefore g of x may be plus root 1 minus x square or minus root over 1 minus x square. Don't combine these two. If you combine these two, the new result is won't give functional relation. So this alone gives functional relation, this alone gives functional relation. My answer is plus root over 1 minus x square or minus root over 1 minus x square. I will show you, students. So my answer is this B and C. Multi-type answer type question, B and C. Okay. Students, third question. Represent all possible functions defined from a comma b to 1 comma 2. Already explained. For example, a is taken as a comma b and b is taken as 1 comma 2. Number of functions from a to b. Already explained formula. N of b power n of a. 2 power 2. 4 functions exist. What he is asking, just represent the 4 functions on the paper. So I will write answer for this. So 1, this is one situation, second situation, third situation, fourth situation. So this is A, this is B, this is A, this is B, AB, AB. Relation F, functional relation F, functional relation F. So I think that is not right way to use it right now. Okay. Okay. So now I want to write what possible functions here. AB 1 2, AB 1 2, AB 1 2, AB 1 2. So this with this is one function. This is another function. This is another function. Okay, this is another function. No other function exists. These are the required 4 functions from A to B. Yeah, students. Next, very important one. That is classification of functions. Types of functions. We have several. So today I want to explain few of them. First, algebraic function. Algebraic function. This is important for us. Algebraic function. Function consisting of finite number of terms involving different powers of independent variable x and the operations plus, minus, multiplication, division are called algebraic function. See here, for example, x square given. This is algebraic function, one of the algebraic function. X power 3 by 2 plus x is given. The expression involving independent variable and involving exponents and some plus and minus symbols. That's why this is called algebraic function. So x power 3 by 2 plus root x by x power 7. This is also another algebraic function. These all are algebraic functions. Okay. One more thing I will write. Just f of x is given x. It is also algebraic function. F of x is called 1 by x, algebraic function only. F of x is called 1 by or square root of x is algebraic function. This is about algebraic function. Some illustrations are given. So complete. This is about algebraic function. Next one. Yeah, polynomial function. Important. F of x equal to, we will write some expression here. That expression should be a polynomial. Such function is called polynomial function. Everyone knows the definition of polynomial. No? F of x is taken as 2x square plus 3x plus 4. This is a polynomial in x. That's why this function is called polynomial function. Okay. Yeah, a function whose domain and codomain both the set of real numbers and contains finite number of terms containing natural numbers powers of x multiplied by real constants is called polynomial function. Just like what they gave here, definition of polynomial is given. Okay. This is about polynomial function. The second one, rational function. Rational function. So, a function f of x should have the form g of x by k of x. G of x by k of x, where g of x comma k of x are two polynomial functions, not only two, more will be, they are polynomial functions. Such function f is called a rational function. So I will write example, f of x equal to x square minus x plus 1, this is a polynomial divided by another polynomial, x square plus 4x plus 9. So this is called a rational function. Rational function means a polynomial function divided by another polynomial function. Such functions are called rational functions. Okay. Yeah, implicit function, very important. Implicit function. For example, say, observe students, f of x equal to some x square minus 1 given. So in general, f of x means what you can write now. This is important notation, students. A and B are two sets. X is paired with y. Y is called image of x under the rule f, or y equal to f of x I can write. In all set notations, instead of f of x you can write y nana. Y equal to x square minus 1. This is the function now. This is what type of function? Polynomial function. Or rational function also I can say. That is not a big problem. So y equal to x square plus 1. In this function, directly you can make x as a subject. Or directly you can make y as subject. Directly you can make y as subject. No, y is x square minus 1. Such functions are called explicit functions. Explicit function. But here what is the implicit function? Implicit function means directly you can't make from that rule y as subject. Some rule is given. The rule is involved in x and y. From that rule we can't find, from equation is given, that equation involving two variables x and y, directly you can't make y as subject. Then you can say that it is implicit function. Or you can make y as subject, it is called explicit function. So implicit means directly you can't make y as a subject. Here f of x comma y equals 0 is an equation into variables x and y. Then y is called implicit function x and y, f of x comma y equals 0. In other words, I can say that directly you can't make y as a subject nana. So this is implicit function. Yeah, okay students, our next concept is algebra functions. Algebra of functions. First of all, I want to explain the meaning of what is algebra functions. Applying 4 fundamental operations on functions. If two functions are given, f of x and g of x are two functions are given. If you add, you get a new function. If you multiply, you get a new function. Subtract, you get a new function. Divide one function, you get a new function. What is the nature of that new function? Means, for example, domain of this function is some k1, domain of this function is k2. What is the domain of resulting function? That is f of x plus g of x, or f of x into g of x, or f of x minus g of x, or f of x by g of x, like that. Algebra of function means applying 4 fundamental operations on the resulting function. Not only 4 fundamental, square roots and cube roots also we can apply. For example, f of x is one function nana, that is x square. G of x is another function nana, that is x. So k of x another function, say root x. Okay. So for example, you can create a new function, f of x plus g of x minus k of x. New function. What is the new function? X square plus x minus root x. This is the rule for new function. Let it be p of x. This is the rule for new function. So how to find its nature, how to find its domain, how to find its range. So that concepts we learn in the part of algebra function, students. Okay. Yeah, students, listen, Nana. Let f of x a function defined as x square. What is the domain, Nana? All real numbers, no? Instead of x, whatever you write, f of x real number only. Or I can, another words I can say that y equal to x square only. Whatever be x, y is real number only. That's why domain is all real numbers. Okay. For example, another function g of x is given as 1 by x. Or another words I can say that y equal to 1 by x. What is the domain, Anna? All real numbers except 0. If x equal 0, y is not a real number. So what is the domain? All real numbers except 0. From R you need to write set 0. So if you add these two, you get a new function. So let it be k of x. K of x equal to x square plus 1 by x. What is the domain of this function? This is interesting thing. Listen, all of you. What happened? This total expression should be a real number. Take any x except 0, anything you can take, it is a real number only. That's why domain of k of x is all real numbers minus set 0. But how can you find another way? So do one thing. First of all, find the domain of this function. Find the domain of this function. Their intersection. The intersection gives the domain of the resulting function. Okay, students? For example, f of x is given as x square, and another function is given as root x. We want to find the domain of that new function, resulting function, that is x square plus root x. Do one thing. Find the domain of this function separately. That is all real number. Find domain of this separately. Root over there, no? X should be greater than or equal to 0. Means our domain is close to 0 to infinity. So what is the intersection of close to 0 to infinity to R? This only, no? Total real numbers and close to 0 to infinity. Intersection this one only. That's why what is the domain of the resulting function? I can say close interval 0 to infinity. That's why, listen all of you. Okay. Yeah, f of x is given as g of x plus or minus k of x. Something like that. A function is given. We want to find domain of this function. You find domain of this first function, domain of second function. Their intersection gives the domain of the resulting function. Okay. For example, f of x is given as g of x by k of x. Find the domain of this function. Find the domain of this function. Their intersection only gives the domain of the resulting function. Okay, students. This is the concept of algebra of functions. Very, very important. Nana. So operations are real functions here. Operations are real functions. Okay. Let f and g be two real functions with the domains d1 and d2. F domain is d1 and g domain is d2. Then we define sum f plus g as the function from d1 intersection d2. Just now I explained, no? F plus g is a new function. Its domain is nothing but d1 intersection d2 to R, which associate x belongs to d1 intersection d2 to the f of x plus g of x. Understood? What I explained, that is the meaning, Nana. So f plus g of x is nothing but f of x plus g of x. What is the meaning of this notation? That is very, very, very important. What is the meaning of this notation? F plus g is a new function, just like k of x, no? K of x. F plus g is a new function. What is the rule of this new function? Means f of x rule should add, and rule of f function and rule of g function should add. What we will get? That is a new rule for f plus g function. That is the meaning here. F plus g of x equal f of x plus g of x, and domain is d1 intersection d2. Okay, the same concept applicable here. Minus is given, same. F minus g of x means f of x minus g of x. Students, are following? So again, I want to explain. F of x rule is given 2x. G of x rule is given as 1 by root x. So this f function, no? This is f function from one set to another function. G function another set to another function. There exists new function that is called f plus g function. F plus g function from another one set to another set. What is the rule? What is the rule for this new function? F plus g of x rule should find. How to find f of x plus g of x? But the meaning of this, rule of first function plus rule of second function gives rule of the resulting function. Here minus is there also, same meaning. Okay. Yeah. Okay. Into also, into. F into g of x rule you want to find. That is nothing but f of x rule into g of x rule should find. But the domain of this means domain of this intersection, domain of this. Division also. So this concept important, Nana. Okay. Now I want explain some problems based on this algebraic functions, Nana. Okay, some problems on algebra of functions. Okay, students. First one, find domain of f of x equal to root over 1 minus x square plus 1 by x. Just now explain a procedure. Find the domain of first function separately. Find the domain of second function separately. Their intersection gives the domain of the resulting function. Okay. Let g of x is taken as root over 1 minus x square. This becomes functional relation. Your 1 minus x square should be greater than or equal to 0. Or x square minus 1 should be lesser than or equal to 0. Or x plus 1 into x minus 1 should be lesser than or equal to 0. Okay, I will change the question. I will write root nana here. Okay, no problem. So what the domain means? By using a Weaver method, I can find minus 1, 0, yeah, plus, minus, plus. I want negative symbols. These are the negative symbols. Or x belongs to closed minus 1 to closed 1. This is the domain for this function. Now I want my domain for next function. Let it be k of x, that one. K of x equal to 1 by root x given. Domain equal to, yeah, x greater than 0. X greater than 0 means what that? Open 0 to infinity. Now you want to find intersection of these two. Separately I will find intersection of these two. First one is minus 1 to 1, closed minus 1, closed 1. Second one is 0 to infinity, 0 to infinity, 0 to infinity. So intersection is this one only, intersection is this one only. So total domain of the f of x, I can say. Domain of f is total function, f is open 0 to closed 1. This is important problem. Okay. Okay, students. Yeah. So present topic is algebra functions. So I want to write some more important properties, Nana. Here, very important. I want to use red color for this. Very important, Nana. Concept for algebra functions. Observe all of you. F and G are two real functions whose domains are A and B respectively. Codomains are R and R. We don't want ranges. So function and domain. A new function. What is the f plus g function? F plus g. How to define f plus g function? What is the domain? That says this rule. F plus g of x equal to f of x plus g of x. For the domain is A intersection B. F minus g of x is nothing but f of x minus g of x. Domain is A intersection B. F into g of x equal to f of x into g of x. Domain is A intersection B. F by g of x equal to f of x by g of x. Domain is A intersection B, provided g of x is not equal to 0. Okay, this is important. I want to use another color. This is another important. K into f of x. Kf of x equal to k into f of x. The domain is A. What the domain of A? That is the domain of this new function. So root f of x. This is inside. Root fx. That is root over f of x. For f of x greater than 0. Okay, students. Mod fx function, nothing but mod of f of x. Domain is, what is the domain of f of x? That is the domain of resulting function. So f plus k of x, just like bracket here. F plus k of x, nothing but it means each element of the function should be added by k. That is the meaning. each element of f means each element of domain of the function should be added by k. K plus f of x equal to k of x plus k. So yeah, its domain is, what is the domain of f? That is the domain. So f power n of x nothing but f of x whole power n, what is the domain of f? That is the domain of A. Through examples I will explain all this, Nana. Please observe. Yeah, interesting problem, students. First problem. A function is given 1 comma 2, 2 comma minus 1, 3 comma 4. Here domain and codomain not mentioned. So assume that domain is 1, 2, 3. Codomain is not there. Range is 2, minus 1, 3. So for this function, you want find a new function, that is 2f function. For example, sometime they will ask f of x is equal to x square. What is 2f function? 2f function. 2f of x means, but just I can say 2x square. For this function, what is the rule means? This is the rule. For new function, what is the rule means? This is the rule. But what is the problem here? The function is not given in a rule form. The function is given in ordered pairs. Okay, f is a function which is given in ordered pairs. So 2f also a new function, we want write in ordered pairs. What I explained previous, that function is given rule, just like x square. What is 2f means? I can say 2x square. But here what is given? The given function only in ordered pairs. Yeah, all this 2f, f square, root f, f plus 3 or 2f plus 3, all should be in ordered pairs form. You need to write one by one. I want write now. Listen, how to write steps, that is important. Solution. First given f equal to 1 comma 2, 2 comma minus 1, 3 comma 1. So it's clearly I explained what is the domain of this function, what is the domain of f, that is the domain of 2f. I will show you. Here, see, what is the domain? A only. So that's why, what is the domain of resulting function? 2f function I want 2f function, ordered pairs I want, 2f function. For the domain of 2f, what is the domain of A? That is the domain of 2f function. That's why, first of all, I want domain of f. Domain of f equal to set 1 comma 2 comma 3. So first one 2f I want find. What the domain of 2f? Same is, you write is same 1 comma 2 comma 3. So what should find, Anna? 2f equal to some ordered pairs you want. For this ordered pairs, what are the first components? The domain of 2f. What are the domain of 2f? 1, 2, 3. Here 1, here 2, here 3. We need to find their second components. Understood? 2f function you want to find, Nana, by using f function. F function domain is 1 comma 2 comma 3. 2f function also domain is 1 comma 2 comma 3 means 2f ordered pairs will start with 1 comma something comma 2 comma something comma 3 comma something only. No? Understood? So this something should find that gives the 2f function ordered pairs. Okay, one by one I will find. 2f of 1 what? According to this definition, what k into f of x, means 2 into f of 1 I can write. That is 2 into f of 1 means what? What the image of 1 here? 2, no? F of 1 image 2 only. Indirectly, f of 1 is 2, f of 2 minus 1, f of 3 is 1 given here clearly. F of 1 is given as 2, f of 2 given as minus 1, f of 3 given as 1. So instead of f of 1, what I can write? 2 I can write. 2 into 2, that is equal to 4. Means in the new function 2f, 1 paired with 4. So 2 into f of 2 I want. That is 2 into f of 2. That is 2 into f of 2. What is the f of 2 value? Where is that? F of 2 is minus 1. F of 2 is minus 1. Should write minus 1. That is equal minus 2. What is the meaning of this? 2 is paired with minus 2 according to the new rule. Next 2 into f of 3 I want. 2 into f of 3. That is 2 into f of 3. Okay. That is equal 2 into f of 3 means what in previous problem? F of 3 is 1. So 2. Under new rule, 3 is paired with 2. Now I will write 2f function is nothing but 1 comma something, 2 comma something, 3 comma something. So what happened in the according new rule? 1 is paired with 4. 1 comma 4. 2 paired with minus 2. Yeah, 3 paired with 2. This is the 2f function. Observe students, how I got, I will explain. F is given as 1 comma 2, 2 comma minus 1, 3 comma 1 given. We want 2f function, 2f function. Just to you want multiply to the second ordered pairs. Just domain as it is 1, 2 2s are 4. Domain as it is, that's 2. 2 into minus 1 minus 2. Domain as it is 2. So this is the 2f. Okay. 3f you want, for example, 3f you want. Same 1 comma 4 3 here f should be, no, I will write again f. Sorry. F is given as 1 comma 2 and 2 comma minus 1 and 3 comma 1 given. Sometimes you want to find 3f. Directly I can write 3f. 1 comma 3 2s are 6. 2 comma minus 3. 3 comma 3. Directly I can write. Okay. Sometimes you want 3 plus f. 3 plus f. 3 plus here all same. No. The domain won't change. Domain of 3 plus f is same as domain of f. 1 comma something. 2 comma something. 3 comma something. What is something? 3 plus f of 1. 3 plus f of 1. So 3 should add it to this 2. That is 5. 3 is added to this 2. 3 is added to this 4. What you will get? That is nothing but 3 plus f. Again I will explain. Just 2f completed, students. 2f completed. Next f square I want. F square. Second one, f square I want. What is the domain of f square? Same. What is the domain of f? That is the domain of f square. Equal to set 1 comma 2 comma 3. So what do I want? How will get done f square? F square equal to 1 comma something, 2 comma something, 3 comma something. Just here only can say answer, no? What is f? I will write again f. I will write f here. F equal to 1 comma 2 and 2 comma minus 1 and 3 comma 1. Okay. F square means just to 1 comma 4. This is squared. This is squared. Actually, this is f square. But directly, how to write answer, I explained. So theoretically, how to write, I will explain now. F square domain is this. Means, what do you want? F square of 1 is equal to dash. F square of 2 equal to dash. F square of 3 equal to dash. What is the meaning of this? What is the image of 1 with respect to new function f square? What is the image of 2 with respect to new function f square? What is the image of 3 with respect to new function? According to the formula, I can write this is f of 1 square I can write. I will show you. This last one. F of n f of x whole power n only. Okay, this is f of 1. F of 1 is 2 only, no? Just I explained here. F of 1 means 2 only. Image of 1. F of 1 means image of 1. In that here, by observing this also you can say f of 1 is 2 only. 2 square, that is equal to 4. Means according to f square function, 1 is paired with 4 nana. Next, f of 2 whole square. F of 2 means what? Minus 1. Minus 1 squared means 1. The next f of 3 square. What is f of 3 here? F of 3 1 only. 1 square 1. Now I want write f square. F square equal to 1 comma 1 paired with 4 1 comma 4 and 2 paired with 1 2 comma 1 and 3 paired with 1 3 comma 1. This is f square. But I already clearly explained. Directly also can find by using this f square directly can find. Domain is same. No change in domain. Squaring of this 4, squaring of this 1, squaring this 1. So 1 comma 4, 2 comma 1, 3 comma 1. That only. Okay. Yeah, students. Yes, root f I want to find now. I will write here only. So I will write here only now. Because f is here only, directly I can write. Root f. Root f. Domain of root f I will write first. What is the domain of f? That is the domain of root f on one condition. No? one condition, the first component should not be negative number. That is important thing. No negative, 1, 2, 3, those are non-negative. That way, those 3 are taken as domain of f. For example, 1, 2, minus 3 is there, then 1 and 2 only taken as the domain of root f. Okay, that also I clearly explained here. See here. Okay, in this problem, domain same, 1, 2, 3. So, what I want? Root over f of 1 image I want. Root over f of 2 image I want. Root over f of 3 image I want. According to the formula, this can written as f of 1 property, sorry. Root f of 1, 2. That is equal to root 2. Yeah, root over f of 2. F of 2 means what? Minus 1. Not a real number. What is the meaning of that? There is no image for 2. In the that is root f is not a function. So, for example, find root f means assume that a relation should find. So, we can't find a function because 2 doesn't have an image. Okay, I will write it last. Root over f of 3. That is equal to root f of 3 means 1. That is equal to 1. Okay. So, root f is not a function. Why? 2 is not image, no? 2 doesn't have an image, but it is a relation. But it is only relation. Sometimes we write what the relations, I will write what the relation. Okay, that is not function, relation. What is root f? I will write here, root f. So what is that? 1 comma root 2. Or 2 comma something, not there. 3 comma 1. So, this is only relation, not a functional relation. Okay, that should take care of that. Yeah, okay, students. Next, third one, f plus 3 I want. What the domain? What the domain of? That only the domain of f plus 3 also. Domain of f plus 3 is set bracket 1 comma 2 comma 3. What should find f plus 3 of 1 image I want. Bracket should use here. F plus 3 new function image for 2. F plus 3 function image for 3 equal to what? Again I will explain the rule here. Where is that? Here the rule, see. F of x plus k separately, that is real number, no? That's why what I can write down here, f of 1 plus 3 I can write. Here what I can write, f of 2 plus 3 I can write. What I can write, f of 3 plus 3 I can write. Okay, f of 1 means what? 2 plus 3, that is equal to 5. So, f of 2 means what? Minus 1, minus 1 plus 3, what is 2? So, f of 3, what is that? 1 plus 3, 4. Now, I can say that f of 3 functional ordered pairs are 1 comma 5 and 2 comma 2 and 3 comma 4. So, directly how to write, that also important. Just domain is same, just we need to add 3 for range. 2 plus 3, 5. 2 minus 1, 1. Actually 3, so 3 no. 3 minus 1, 2. 3 plus 1, 4. Okay. So, for 2f plus directly I will write answer. I don't want to waste my time. They are easy only. No? 2f plus 3 directly I want to write. 2f plus 3 equal to, domain is same, 1 comma something, 2 comma something, 3 comma something. What is something? 2 into this range, 2 to the 4 plus 3, 7. That 2 minus 2 plus 3, 1. Yeah, 2 plus 3, 5. So, this is the 2f plus 3, or theoretically also you can find 2f plus